It's time to talk about the eicosanoids, which are a class of lipids that act as signaling molecules that bind to cell surface molecules. In biochemistry, the eicosanoids they're made by oxidation of 20 carbon fatty acids, and they exert complex control over many body systems, mainly in inflammation and immunity, and are messengers in the central nervous system. So what I want to say here is that the eicosanoids are rapidly broken down and therefore act in autocrine or paracrine pathways and stimulate a variety of responses in the target cells, including blood platelet aggregation, inflammation, and smooth muscle contraction. So, talking about prostaglandins, for example, they act in the contractions during childbirth. Also think about prostacyclin and thromboxanes and leukotrienes. So, talking a little bit more about them, think about eicosanoids and how they're synthesized from arachidonic acid. And remember that the first enzyme involved in their synthesis is cyclooxygenase, or COX. You may know COX-1 and COX-2. And this enzyme COX-1 or COX-2, this is the target of aspirin. The actions of aspirin is to reduce inflammation and pain. So this is the inhibition of the prostaglandins. Aspirin reduces platelet aggregation and blood clotting. So this is the work of thromboxanes. The applications here would be the prevention of strokes and to reduce the frequency of colon cancer. Anyway, so this was a very short introduction into the eicosanoids as a signaling molecule. Just remember that they bind to the cell surface molecules and include prostaglandins, prostacyclin, thromboxanes, and leukotrienes.